All right, in the world of IT, we're used to tackling problems we can see, right? Things we can measure. But what about the ones we can't? So today, we're going to talk about the invisible forces all around us, from weird radio waves to literal cosmic storms that can totally disrupt the technology we depend on every single day.
Now, just so you know, this is part 7 of our 10-part deep dive. It's all based on an incredible report called An Introduction to Radio Frequency Interference, or RFI, Electromagnetic Interference, or EMI, and Space Weather for IT Professionals from the folks at RFI Detectives. It's designed specifically to help IT pros like you get a real handle on this tricky subject. So, let's jump right in. Oh man, we've all been there, right? You've checked the network configuration, you've rebooted the access points, you've triple-checked the firmware, and yet the connection is still garbage. The help desk tickets are piling up, and you are just running out of logical explanations. It's maddening.
So what if the problem isn't in your software or even in your hardware? What if the culprit is something totally invisible, a silent wave of energy that's causing absolute chaos on your network? Yep, we're talking about electromagnetic interference. Okay, so to really get a handle on this stuff, we've got to speak the language. Let's break down the two big terms you're going to hear all the time when you're dealing with this kind of electronic static: EMI and RFI. So, first up, you've got EMI, which is short for electromagnetic interference. Now, the easiest way to think about this is as the giant, all-encompassing umbrella term. It covers any kind of electrical disturbance from an outside source that messes with an electrical circuit. It's really the parent category for all the electronic noise out there. Okay, so under that huge EMI umbrella, we're going to zoom in on the one that really matters to us IT pros, and that is RFI, or Radio Frequency Interference. This is the unwanted junk energy that lives specifically in the radio spectrum, exactly where our Wi-Fi, our Bluetooth, and all our cellular signals are trying to do their thing. In this chart here, it lays it out perfectly. See, over on the left, you've got EMI. That's the big picture, the entire spectrum messing with any circuit. But over on the right, that's RFI. That's our specific headache. It's just the radio frequencies, and it's lasered in on our wireless communication links. So remember, all RFI is a type of EMI, but not all EMI is RFI. And this brings us to a really crucial point, and it's an absolutely fantastic analogy from the source material. For IT pros, you should think of RFI as the wireless version of electrical noise on an old data cable, right? Just like that static can corrupt data packets on your Ethernet cable, RFI scrambles the signals flying through the air. And that's what causes those dropped connections and infuriatingly slow speeds.
All right, so we get it. A leaky microwave in the break room, a bad power brick, we can wrap our heads around that kind of interference. But what happens when the source of that interference isn't something we can just go unplug? What if it's, the single most powerful thing in our entire solar system?
And that, my friends, brings us to the threat from above. We're about to shift our focus from those local, earthly troublemakers to the ultimate RFI source, our very own sun, a cool 93 million miles away. So this is where we start talking about something called space weather. And no, it has nothing to do with rain or clouds. We're talking about the constantly changing conditions on the sun and out in space, things like solar flares and geomagnetic storms that have very real and sometimes very powerful effects on all our tech right here on Earth.
And this is exactly why it's so critical for IT pros to understand. Think about it. You can track down a noisy appliance and shield it, right? But you can't exactly turn off the sun. You can't put a filter on a solar flare. And that's what makes space weather maybe the least intuitive, but potentially the most devastating type of interference you could ever face.
The core lesson in all of this is summed up perfectly right here. In the RF domain, small causes can produce large effects. And that's so true. Whether it's a tiny little gadget causing massive local problems or a solar storm millions of miles away, the world of radio frequency is a place where small things can have absolutely huge consequences. Our systems have to be built to handle these scenarios that might seem, improbable.
Okay, so if we can't stop a solar storm, what on earth are we supposed to do? Well, this is where we have to totally shift our thinking. We have to move from trying to prevent it to being prepared for it. It's all about designing our systems for disruption.
And the key strategy here is a concept called graceful degradation. Look, since we can't stop a major space weather event from happening, we have to design our systems to fail, gracefully when those critical services we depend on get hit. For example, what happens when GPS timing signals go haywire? Does your system have a fallback? Can it switch to an internal clock? even if it's a little less accurate, just to keep the most essential services online? It's all about having a plan B for when our cellular, GPS, power grids, and satellite links get knocked around.
And that really brings us to the final big question. I mean, every single one of us has a disaster recovery plan, right? Your plan almost certainly covers things like fires, floods, maybe a major power outage. But here's the challenge. Go back and look at that plan again. Does it account for a storm that starts 93 million miles away from your server room? That's a question we all really need to start asking.